Hello everyone, welcome to our channel, the Digital Institute of Computing Technology. In this presentation, we will have discussion on the topic Standard Library for Strings in C programming language. We have standard library functions to perform common operations on strings. The C standard library provides essential functions for string manipulation, and having these functions in a library is needed for several key reasons. The library functions offer a consistent and standardized way to handle strings across different C programs and platforms, ensuring uniform behavior and compatibility. These functions are optimized for performance and reliability by experienced library developers. They simplify common tasks like copying, concatenation, and comparison, making code easier to write and understand compared to implementing these functionalities from the scratch. Additionally, they provide safety, portability, and helps in maintaining code quality. We need to include the file string.h, the header file, to use this function. Now let's see some of the commonly used standard library string functions. String length. This returns the length of a string, excluding the null character. Example, yes is a string of size 10, initialized with hello. String length of s will return the length of the string s, which is nothing but 5. String copy. Copies a string to another string. It accepts two arguments, destination string as the first argument and the source string as the second argument. String copy will copy the source string to the destination string, dest in this case. String ncopy copies a specified number of characters from one string to another. It accepts three arguments, the destination string as the first argument, source string as the second argument, number of characters to be copied from the source to the destination as the third argument. String ncopy will copy the three characters of string s to the string dest in this case. String cat appends one string to end of another. In this case, string cat appends the string there with dest, which contains hi. String compare function compares two strings lexicographically. String comparison is essential for sorting, searching, and validating strings. String compare provides a standardized way to compare strings. String compare accepts two arguments, the strings to be compared. It returns 0 if they are equal and a non-zero value otherwise. str finds the occurrence of a substring in a given string. str in this case will check the presence of world in hello world. strchr finds the occurrence of a character in a given string. We'll check the presence of e in the string hello and returns the position of the first occurrence if it is present. strrrchr finds the last occurrence of a character in a string. We'll check the presence of l in hello and returns the position of the last occurrence of l if it is present. String dup duplicates a string, allocating memory for the new string. This will create a new copy of the string hello and returns its address. String top splits a string into tokens based on the delimiter. In this case, the delimiter is comma and the string to be tokenized is hello world with a comma in between. This returns two tokens, hello and world. Now let's try to use some of these string functions in our programs. Consider the isPalindrome function in our last example, which was implemented to check whether a string is palindrome or not. Now let's try to minimize this logic into a simple one-line function using string library functions. The string reverse function will take the original string and return the reverse of that string. The string compare function will compare the two strings provided and will return a value 0 if they are equal. Otherwise, it will return a non-zero value. Whenever a string compare function returns 0, it means the two strings provided to this function as arguments have the same value. So pass the original string and the reverse string to the string compare function. To reverse the string, you can use string reverse function. Now, original and reverse string will be compared. If they are equal, string compare will return 0, otherwise it will return a non-zero value. If the string is a palindrome, output is 0. If the string is not a palindrome, the output is 1. So this is the magic of the library functions. They help us in reducing the code size to a considerable degree. Here, a 15-line code was reduced to a 1-line code. Both the functions will return the same value. Only difference is the function size. In the first case, it was 15 lines without a library function, and in the second case, it is 1 line with a library. Now let's use this function in our program. In this program, the main function calls the function isPalindrome with Malayalam in the first case and Kannada in the second case. For string Malayalam, isPalindrome function will return 1 because string Malayalam is a palindrome. For string Kannada, isPalindrome function will return a 0 value because string Kannada is not a palindrome. The output of this program is the string Malayalam is a palindrome. The string Kannada is not a palindrome. Let's see one more example. Let's try to write a function to check the presence of a substring within a main string using a string library function. Can we apply the same logic what we used to check the presence of a character within a string? Yes, we can. Example, in the string hello, we want to check the presence of ll, whether ll is present in hello or not. The function receives a string and a substring whose presence is to be checked as arguments. If the substring is present in the main string, the function returns 1. If the substring is not present in the main string, the function returns 0. We will iterate through the entire string. We'll try to start by finding the presence of a substring from the first character. So let's start from the first character to check the presence of a substring in the main string. If all the characters of a string matches with the characters of the main string, from the current position, a match is formed. If there is a match, we'll stop the search by breaking the loop, otherwise we'll move to the next position. We repeat this until a match is formed or the string has been traversed up to the last valid position. So let's assume the main string is hello and the substring is ll. Then what happens? str of I will point to h and substring has ll. So the first character of the substring is l. L is compared with h. They do not match. So the loop continues. Then I points to e. Again, e is compared with l, the first character of the substring. They do not match. In the next iteration, I becomes 2. At this position, in the main string we have l, and the substring also has l. From this position, all the characters of the substring will match the characters in the main string. So what is the length of the substring in this case? Since it is 2, it will try to compare 2 characters only. If both are found, it means substring was found in the main string. Substring of length 2 was found at the position 2 in the main string. The string compare function will return a value 0. When it returns a value 0, it means the substring was found at the current position. The variable found is assigned a value 1 and the loop breaks. So this is a successful case. What about an unsuccessful case? In unsuccessful case, every time string compare function checks the presence of a substring at a particular position, it will return a value other than 0. So next iteration of the loop continues. This continues until the last iteration. But for how long the iteration should continue? The last value of I will be main string length minus substring length. For instance, say the length of the main string is 10 and the length of the substring is 4. Then what is the difference between the length of the main string and the length of the substring? It is nothing but 10 minus 4 equal to 6. So the last value of I should be 6. We cannot go beyond 6. Why? Because if you go to the 7th position in the main string, only 3 characters will be left. Now you are checking a substring of length 4 with the left out characters 3, which is meaningless. In order to ensure the main string has number of characters to be searched equal to or greater than substring length whenever it is calling string compare function, we need to check that the value of I does not exceed the main string length minus the substring. Now let's use this function in our program. In this program, the main function calls the find substring in string function with hello and ll in the first case and hello and ab in the second case. For the first case, find substring in string function will return 1 because the substring ll is present in the main string hello. For the second case, find substring in string function will return a value 0 because the substring ab is not present in the main string hello. The output of the program is 1 for the first case, 0 for the second case. So this is a simple logic to check the presence of a substring within a main string. Now, can we extend this logic to find the number of times the substring is present in the main string? Every time a substring is found, increment the value of found by 1. In this case, we will not break the loop when the substring is found in the main string. We will continue the loop. Additionally, I can be incremented by the length of the substring minus 1. Why minus 1? Because by default I is incremented by 1. The function returns the value of found as output, which is nothing but the frequency. If the frequency is 0, it means substring is not found. If the frequency is 1 or greater than 1, it means substring is present so many times in the main string. Hope you liked and enjoyed the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.